Hi everyone. This chapter we will be learning about similar triangles. It is chapter 7 in your book. We need to start with ratios and proportions. These are very important for similar triangles, so we need to make sure that you know how to solve these. So a ratio, you should know, is a comparison of two quantities. You can write it in many different forms: A to B, A with a colon B, or A over B. We can also divide this out and have a decimal. So for example, you see ratios in your real life in places like baseball. So on this problem it says a baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks. The Minnesota Twins' Joe Mauer had the highest batting average in Major League Baseball in 2006. If he had 521 official at-bats and 181 hits, find his batting average. So in the problem it tells us his batting average, the formula, you can use the number of base hits, not including walks, over the total number of at-bats. In this problem, it tells us that Joe Mauer was able to get on base 181 times by hitting the ball, and he had a total of 521 opportunities to hit the ball. That's how many at-bats he had. So this is a good answer, but normally batting average is given as a decimal rounded to the nearest thousandth place. So we can go ahead and divide this out. I'll type 181 divided by 521 into my calculator and round it to the nearest thousandth. What this means is that his batting average was 0.347, which is clearly very good because he had the highest in the league. If any of you are baseball players, you can compare your batting average, and now you know how to find it. Alright, you can check your answers. For part A, it says that the approximate student-teacher ratio is about 14 to 1. I reduced 2,650 over 190. I divided it in my calculator and I got 13.947, and I just rounded that up to 14. I obviously can't have 13.9 students, and it's an approximation. What this means is that approximately for every one teacher there are 14 students on average. It's not perfect, but for part B we did the same process. I took 500 divided by 32 to get 15.6, which means that there's about 16 students for every one teacher. We can also use something called an extended ratio. This is used to compare three or more quantities. It would be written A to B to C. This first example, we are going to use the measures of angles in a triangle. It is 3 to 4 to 5. Now we need to find the actual measures of the angles. So if you want, you can start by drawing a diagram. And what I know is that the angles are in this proportion 3 to 4 to 5, this ratio. So what I can do is label my angles 3x, 4x, and 5x. Now, I know that the angles of a triangle must add up to 180 degrees. So I'm going to take these three angles and make sure that they add up to 180. I'll combine my like terms to get 12x, and then divide by 12 on both sides to get x equals 15. It asks me to actually find the angle measures though, so I need to go ahead and plug x back in. So I have the angles are 3x, so 3 times 15, 4x, 4 times 15, and 5x, so 5 times 15. I can simplify each of these: 45 degrees, 60 degrees, and 75 degrees should be my angle measures. How could I check this answer? Well, I could make sure, do these three angles add up to 180? Sure enough, they do. Pause the video and try the practice problem below. This one deals with perimeter, but hopefully you know that perimeter means the sum of all the sides in the shape. So you will add up 3x, 3x, and 8x. This one you did not have to find all the side lengths. It only asked you for the longest side. So we only needed to take 8 times 28 to solve. Now let's talk about solving proportions. A proportion is two ratios equal to one another. So in a proportion, the product of the means are equal to the product of the extremes. So you've probably heard of this, cross multiplying. We know that in this proportion, A times D should be equal to B times C. I can use this to solve proportions. What I can do for a simple proportion like this is just cross multiply and divide. If I'm trying to solve for my variable x, I will cross multiply the extremes, so I have 6 times 31.5, and I need to divide by 21 to get x by itself. So I know that 6 times 31.5 is going to equal 21 times x. I always will end up cross multiplying and dividing to get the variable by itself. So if you want to do that all in one step, once you are comfortable, that is fine. So we'll multiply 6 times 31.5, that gives us 189. Divide that by 21, and we'll get 9. Now let's talk about if we have something added to our variable. Now we have two variables in this proportion, one on each side of the equation. We also have something added. So this time we can't just cross multiply and divide it. It's a little more complicated. So we'll multiply 5 times x plus 3, set that equal to 2 times 4x. You should know how to solve this equation. Distribute the 5. Multiply 2 by 4x to get 8x. Next, subtract 5x on both sides, and divide both sides by 3 to get, finally, x equals 5. I'd like you to pause the video and try the 3 practice problems below. Here are the correct answers for the first 2. And finally, the final answer. You can also use proportions to predict. So this problem says Fernando conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drive to his school, predict the total number of students who own cars. So what he did was he found the number of people who own cars, and we also know we can find that ratio of the number of people who own cars to the total number that he surveyed. That ratio would be 28 to 50. 28 of them owned cars out of the 50 who he surveyed. Now, if we're going to use this to predict the total number of students who own cars, we're going to assume that it's proportional to the whole school. Now, I need to put the total number of students in the denominator here because I put the total number surveyed in the denominator before. That means in my numerator, my variable will tell me the number who own cars out of the entire school. You should know how to solve this. We just did one. Cross multiply and divide. So I have 755 times 28 divided by 50. If you need to take 2 steps to do that, that's fine too. This gives me, in my calculator when I type it in, 422.8. What that means is that about 423 students own their own car. Okay, finally, here's what I want you to reflect on today. I want you to look at these 4 proportions and see if you can identify the proportion that does not belong with the other 3. Explain your reasoning in 1 to 2 complete sentences. Tomorrow, we will actually be able to apply these to shapes, and we will talk more about similar polygons. So I'll see you then.